Scientific notation is something you've seen several times, and the simplest thing to look at is that it's just telling you it's not actually, this number is not actually 2.834 because of this. And so what it's telling you is that the decimal needs to be moved, and this is giving you a clue as to how to move it. If it's positive, you're going to move the decimal to the right to make the number bigger. You'll see instead of a 2, it's a 283. If this is negative, you'd make it to the left so that it'd be smaller. It'd be 0.002. So since this one is, sorry, I went too far, 0.02. Since this one is a positive 2, we're going to move it to the right. And so we can look, and if we move it to the right 2 places, we get 283.4. And that's what that number really is. This is called the standard form. And so if you're asked to put something in standard form, you're going to ask, what is it really? What number is it really? And this is called scientific notation form. Okay, standard form is also called decimal form, by the way. All right, so some other things, the new stuff that we're going to be looking at. What if you want to multiply to scientific notation? Now, all of this is multiplication. I've got this multiplication here between these two numbers. I've got this multiplication between these two numbers. And then I have this multiplication between these two scientific numbers. And so really, I have a bunch of multiplication going on here. So I can rearrange, because multiplication, you can rearrange to whatever order you want. And what I'm going to do is I'm going to rearrange it so I take these first numbers and multiply those. And so if I do that, if I multiply those first numbers together, I'm going to get 10.64. And then I'm going to multiply the tens together, and since they're the same base and I'm multiplying, I'm going to add the exponents. So then I get 10 to the 7th. 4 plus 3 is 7. Okay, so I've got 10.64 times 10 to the 7th. Okay, now it would be lovely if I could say I'm done, but this actually is not in scientific notation, because a big part of scientific notation is that the decimal can only be after the first digit. So I need the decimal to be after the 1. So I've got 1.064 times 10 to the, and now I got to figure out what my exponent is. Now it used to be 7. When the decimal was here, it used to be 7, meaning you had to move 7 places to the right to get to the answer. But now I have to move it another place. So that means I need it to be an 8, because I have to move it one more place to get it to be the answer. I have all the 7 right here, and then I have that extra place that I moved it to. So this is actually my answer, 1.064 times 10 to the 8th. Okay, what if I wanted to divide? Well, once again, I can do things in whatever order I want here. I'm going to divide these two, which gives me 0.25. And then, because I'm going to divide these two and they're the same base, so I'm going to subtract the exponents. So it's going to be a -1 minus a -4. So writing it down is a good idea, because here's one of those confusing ones. And I get the two negatives become a positive. So -1 plus 4 is 3. Once again, it'd be great if I was done, but no, I have to write this as a scientific notation, which means the decimal has to be after the 2. And so now I want to figure out what is my new exponent. Before I had to move it 3 to the right to get to my actual answer, but now I've moved the decimal here, so now I only have to go 2 to the right, so it's a +2 will be my answer here. And the last example is, what if you're raising it to an exponent? Okay, so I'm going to distribute this to both of them. So I have 4 to the 3rd times 10 to the, I multiply the exponents, -6. And 4 to the 3rd is 64 times 10 to the -6. And once again, this is not scientific. I have to move it to scientific. So it's 6.4 times 10 to the... Now, the decimal was here, and I had a -6, so I had to move it 6 to the left. Okay, but now the decimal's here. So now I only have to go 5 to the left, so it's -5 as my exponent.